Welcome back, boys and girls, to the Beginner Game Programming Series. I'm Chili, and this is Lesson 16. We're going to get started on today's topic real soon, but before we do that, I have a little something I want to share with you. Well, XX was at it again. He's got another game out. Another one. The man is a machine, I swear. So, this one is pretty fucking hard, man. I haven't beat it yet. I've played it a few times, but I haven't managed to collect all of the faces. Grr. So as you can see, he's expanded the world now, so it ranges over many screens. And he's got scrolling implemented here. He's using a lot of the scroll. God damn it! He's using a lot of the scrolling code that I provided on the forum. So yeah, that's well done. And the minimap is pretty sweet. Platforming is good. It's all good. It's got his own music in the background there. It's very impressive. This just shows what you can do even right now, just with the skills that I've shown you so far. This is using nothing that I haven't shown you, so much is possible. Alright, let's get on with it. Today's topic is pointers. Ah yes, the dreaded pointer. The bane of many a veteran and student programmer alike, for different reasons. I guess students just have a hard time understanding how the fuck we gotta use these things and what they're for. Whereas veterans, their problem is more about how to use them without, cutting their foot off or something. We're gonna focus right now on just how they work and what the hell they are. And we'll worry about the more complicated stuff for some other day. I'm gonna give you a nice introduction to pointers here. Now, I think when I first started learning C, I didn't take any classes or anything. I had like a reference book and a compiler with some example source code. And I didn't really get pointers to begin with. But I think one of the main reasons why I didn't get them and why maybe some other people don't get them either is that to understand pointers, really you have to understand what's going on in the memory, how the computer is accessing the memory and how the compiler is organizing the variables in memory. If you can understand that, then I think pointers, they aren't really all that difficult at all. So that's how I'm going to approach the topic. Now, the savvy among you may have noticed in some of the other lessons, I have been kind of sneaking in memory organization and memory access into my tutorials. I've been kind of showing you how the computer actually accesses the variables in memory. And we're going to be doing that here. The main reason for me doing that was just to prepare you for this day. Now, I'm serious because I made like a real serious diagram thing here. I didn't just like chalk something out in pen with my usual chicken scratch. So we're gonna be getting some serious learning on today, friends. But don't worry, you also get a lot of my chicken scratch too. So first thing I want to do is I want to define a function that we're gonna have here. We'll call it print. And what this function will do is it'll take a variable, a single variable, the type doesn't matter, and it will print the value of that variable on the screen. Well, it'll get passed some kind of value and it'll print that value on the screen. That's a better way of saying it. You don't pass variables to functions, you pass the values of those variables. So yeah, we have this function and we're going to use it. But right now, the first thing we're going to do is we are going to declare an integer. So we'll declare an int x here. So how does that work? Well, the compiler looks at the stack, which is the place where our variables are stored, and it finds the next unoccupied address, which in this case is address 0042. And it says, okay, 0042, you are now variable x, which is an integer. So it stakes out a little space on the top of the stack for variable x. And then we can do something like, right now, the contents of x, or the contents of address 42, we don't know what it is. It's garbage right now. So let's put some legit number in here. We'll put a 5 in there. So how does this work? Well, first thing the compiler does, it says we're gonna be moving something into x, so we have to know where x is. It looks at its table of variables here, and it says x is at address 0042, and then it jams a 5 into 0042. Mission accomplished. Let's try something else here. Let's try printing out the value of x. So how does this work? Well, again, the compiler says we're going to need to be retrieving the value of x. So x is at 0042. It retrieves the value of 0042, which is 5, and then it passes that value to the print function. The print function executes, and a 5 is displayed on the screen. So far, so good. I hope I haven't lost anyone yet. Let's switch it up a little bit. Let's declare a float f, but we'll declare an array of floats. So we'll declare an array of 3 floats. So how is this declared? Well, again, next unoccupied location in the stack, we call it f. We note that f holds floating point values, and then we don't just stake out one spot in the stack, we stake out 3 locations here. So we do this. We'll carve out a nice little piece of real estate for our array, and everything is hunky-dory. Now we're gonna move some value into our array. So let's go f at 1 is equal to x. How does this work? Well, the compiler or the computer, or whatever you want to say, looks at its table. It says x is at the address 0042. It retrieves the data stored at 0042, which is a 5. Then it looks at the address of f, 0043. It adds 1 to that address because we're accessing element 1, and gets the address 0044, and then it stores the retrieved value, the value retrieved from x, into 0044. No. Wait. Before it stores the value, it converts this integer into a float. Then it stores the value in here. We get 5.0f. Yeah, I caught it this time. Fool me once, shame on. You fooled, you can't get fooled again. Alright. Now. And again, we could call print on f1 and we'd get, 5.0f. But whatever. Whatevs. Let's try something a little different here. Here's one you haven't seen yet. We're going to, let's say in a header file or something, we define a structure, and we'll call the structure foo. And this structure, it contains a float A and an int B. Don't forget the semicolon. Alright, so now let's declare a foo object or a foo structure, and we'll call it bar. And when you do this, next unoccupied spot is for bar, type foo, and because this structure has two members, we're gonna carve out two spots here in memory for this structure. Alright. And now we can say something like, I don't know, bar dot, what I want, B is equal to F1. Alright. Again, how does this work? Well, first we got to retrieve the value from our array. So we look at F is 43, we add 1, 44, we retrieve 5.0F from address 0044. Then we convert that to 5 integer. Then we get the value of, we look up the value of bar, which is 0046, and we note that B, 0, 1. B is the second element in the structure. So we add 1 to 0046, 0047. We store the retrieved and converted value into 0047. Right? Because obviously, yeah, foo or bar dot A corresponds to 0046, bar dot B corresponds to 0047, because that's the order that the variables were declared inside of structure foo. Okay, so all of this is, there's nothing, I hope there's nothing too incredibly surprising in all of this, because I've pretty much gone over this shit before. Now it's time for something a little different, friends. Let's declare a pointer. How do we declare a pointer? Well, first we put a type. So we're going to put the type fuck. No, don't put the type fuck, because that's probably not a type. Unless you I mean, you could make a type that's fuck. But we're going to do a type int, and then we're going to put an asterisk behind it. Why? Because we like it like that. And also because this will make it a pointer. The name of our pointer will be P. So this declares a pointer P, which is used to point to integer variables. What the compiler will do is it'll go to the next unoccupied space, and just like any other variable, it will carve out a chunk for P, and it will note that P's type is pointer to int. Alright, so now we got this pointer. Now we gotta make it point to shit, because that's what pointers do. Savvy? So we go P is equal to ampersand, bro. We get the ampersand out. Now what the fuck does this mean? Well, pointers point to shit, and when you go ampersand x and you assign that to P, you're telling P, hey P, point to X. Point at this guy. So let me break it down for you. Let me give you the play-by-play. The ampersand operator, when used on a single variable, is known as the address of operator. If you can't tell what that name does, then if you can't tell from the name what this operator does, then well, you ain't that savvy. But I'm gonna explain it for you anyways. Let me explain it to you, bro. The ampersand operator will resolve to the address of the variable that it's operating on. So for example, ampersand x will resolve to 0042 because 0042 is the address of X. So what this does is, well, what'll happen is when this gets to the compiler will look up X, and X is 0042, and it will not then cause the computer to retrieve 5 from memory. It will just return, or it will evaluate to 0042. And then that value will be stored in P. So then the compiler will look at P, it'll say P's address is 0048, and it will store 0042 into 0048. That's right. Pointers, they do not hold normal values. Pointers hold address values. They don't give a shit about your values. They want addresses. You can use your values to line your panties. So, this one will put the address of X into our pointer P. And now that the value of pointer P is the address of X, that means that P is pointing to X. So what do we have here? Well, not much, but what we can do now is, because P is pointing to X, we can now manipulate X using P. It's like a remote control. It's like you got like a little marionette puppet on the strings, and you're like, dance, puppets, dance. So let's make them puppets dance. First, you got to put an asterisk, and then you put P. What this does is it tells the compiler that whatever we're going to do here, do it to the thing that P points to. Don't do it to P itself. We want to work on the thing that P is pointing to. And because the address is 42, P is pointing to X. So if I go star P is equal to 1, what'll happen here is, the first thing the compiler will do is it'll look up the address of P. P is 48. Then it will retrieve P's value. P's value is 0042, right? It's an address, 0042. Then, this is the, by the way, this asterisk here, when used in front of a pointer, is called the dereference operator. I'm not making this shit up, man. You can Google that shit. So, where was I at? Okay, so the compiler looks up the address of P, then it retrieves the value of P from memory, then it stores 1 into the address that P was holding. So the retrieved address becomes the target for this assignment, and 1 gets moved into 0042. So in effect, we have changed X's value. This is almost as if we put X here, except we didn't put X here. We put P, and we put a asterisk in front of the P. And by doing that, we can manipulate X from a distance, as it were. Very sneaky. So, now, let me ask you a question. Let's do something like print star P. What value will be pooped out of the display here for us to see? What will the value be? The value will be 1, because we are operating on the target of P, and P's target is X, and X's value is 1. Right? If you said anything other than 1, then you failed. So what'll happen here is, again, the compiler looks up the address of P. P is 48. It retrieves the value of P, which is 0042. Then it retrieves the value at 0042, which is 1, and then it passes 1 to the print function, and the print function poops out a 1 on the screen. Now let me ask you this. What if we do print P? What'll this do? The answer, well, again, we look up P. P is 0048. We retrieve P. 0042, and then we pass that value to print, and we get 0042. So if we do a star p, we get x's value. But if we just do p by itself, we get p's value. And that's how that works. What if I were to do print? This is pernt. What if I were to do pernt ampersand, I don't know, ampersand bar dot b? What's the value? The value is 0047. That'll be printed out, right? The address of bar b. What if I were to do print ampersand f2? F at index 2 is 0045, 0045. That's what it is, bro. So what if I were to do this? We're running out of space here, so I'm going to keep this short. P is equal to ampersand bar dot a. Well, first thing it does is it looks up bar's address 0046. It's bar.a, so it's the first one, 0046, and this is the address of operator, so we just get the address 0046, and then we move that into p. P is 0048, so we move 0046 into 0048. 046. And then I can do something like, I can do something like p star p is equal to 0.5f. What happens? Well, p is 0048. We retrieve the value of our pointer, which is 0046, and then we store 0.5f into 0046. 0.5f, right? Okay, so I think I've shown you guys enough examples of how this shit actually works in memory. I'm hoping this will be sufficient for you to get an idea of how to use a pointer. So the basic things to remember is you declare a pointer, you put the type that it has to. Oh, I fucked it up. I fucked this up. Can you see where I fucked it up? Yeah, here it is. I made p point to bar.a, but bar.a is a floating point number. P points to integers. So if you were to do this, if you were to write this code, the compiler would say, what? What the fuck you talking about? Get the fuck out of here. So yeah, I can't do bar.a. I'd have to do bar.b, and that would work, but I couldn't do it floating point. Well, I could, but it would have to convert. So I'll say that this one's equal to 6 or something. And it's bar.b, so the address stored in p would have to be 47, and that means that 46 wouldn't change. It would remain uninitialized, and 47 would change from 5 to 6, because here we got a 6 stored here. We're storing a 6. Okay, so I fucked it up, but I also caught myself before I uploaded the video, and that is good. Now, what was I talking about? Fuck, now I can't remember what I was going to say. God damn it. Oh yeah, okay, so when we're declaring a pointer, we put the type that the pointer is going to point to, we put a star or an asterisk, and then we give the name. Then when we want to make the pointer point to something, we use the address of operator. So we put the variable as normal, but we put the address of operator before the variable, and that shows that we're going to make p point to it. What's actually happening is we are evaluating the address of x here, or we're extracting the address of x, and then we are assigning that address into p. We're moving it into p. And when we want to access our pointer targets, we put a star in front of p, And that means that we want to access the thing that P is pointing to. We want to access P's target. And you can do that to move values into the target, or you can do that to retrieve values from the target. Okay, that is pointers. Now, let's forget about pointers for a second. I just want you to clear your mind of all stuff and junk. And I want you to open up a fresh, clean framework here. So you can create a new folder for the framework if you have to. And I want you to use the newer version of the framework. For this thing, we're going to be using the framework version 12.4.24. So I'll put that on the download section on the forum, and you can go to the forum and you can download. It'll be under lesson. It'll be in the download topic under lesson 16. So you go there, and you can download the framework version that we're going to be using here. And download that and make a new folder, and it'll all be good. Now we're not going to be using sound or any of that shit, so forget about it. I'm just going to close all this here. Okay, so I'm hoping that you guys you've got your framework, your new folder all set up, and you've got your framework opened, your solution opened up. And you're going to go to game.cpp. And then I'm going to have a drink. Alright, so did I say game.cpp? Because I meant graphics.cpp. Let's check it out. Let's delete this. Let's close this output window. It's cramping my style. And we'll check out the drawLine function. So we made drawLine a little whiles back, and when we made it, to overcome a bunch of problems in the algorithm, we made a number of additions, and one of the additions here was that we swapped the values of our points, P1 and P2. We swapped their values, so we swapped X1 and X2, and we swapped Y1 and Y2. For example, in this case, if dy is less than 0, meaning if our delta y, if our y is sloping downwards, we want to switch the values of P1 and P2 so that now it'll be sloping upwards. We want to redefine which point is the starting point and which point is the ending point, basically. And we do that so that our loop can always loop in the same direction. And it worked fine. So here we're just swapping x1 and x2, and here we're swapping y1 and y2. And again, in the case of an x-dominant slope, if dx is less than 0, we swap x1 and x2, and we swap y1 and y2. Now the thing is that this code here is very repetitive. We're doing the same operation 4 times. So sometimes what you would want to do is you'd want to create a function that can do this, and then instead of repeating the same code over and over again, you just call the function. So we're going to do that here for no reasons whatsoever. We're going to call the function swap because we want to swap the values of 2 integers here. So if I can find my home row on my keyboard, here it is. We'll go void swap int x. We'll say int x1, int y. No, x2. Doesn't matter what we call them, but if I call them x1 and x2, then I can just copy this code here and paste it here, and it's all good. Right? Nothing could possibly go wrong if I do this. Genius. Simply genius. Note that I'm declaring this as just a global function because it's a general purpose utility swapping. You could use that anywhere. And I mean, I'm lazy, so normally I would put it like in its own header file or something, but I'm just going to put it right in front of the place where I'm going to use it. So as long as it's defined before it's used, it'll be fine in the compiler's eyes. So now I've got my swap function, so I'm going to replace this here. Swap x1, x2, swap y1, y2, and again, in this case, we just do the exact same thing. Okay, now doesn't that look much cleaner and just easier to read? I'm liking this idea more and more as the days go by. I mean, whatever. And I'll compile it. Works fine, works like a charm. So now we need to test. We need to be able to test that that the version of draw line with the swap call works the same as the version without. So we need to write a little test code. So now we'll open game.cpp. And if you haven't been keeping up with my updates to the framework, we can use the mouse now. We have some mouse functions, so let's use that. So we'll go if mouse.is in window. Then we'll do draw line, bro. Draw line. X1 and Y1 will just be the center of the screen. So 400, 300. We'll draw a line from the center of the screen to the current coordinate of the mouse. So get mouse X, mouse dot get mouse Y, and we'll just make the color. We'll just make the line white. And there you go. We have a winner. Hot dog. We have a wiener. We'll compile that. Make sure I haven't fucked it up. And run. Run. Okay, so looking good so far. We've got our line. It's drawn to the end of our pointer. And oh God, what the hell? Our line disappeared. What the shizzle? So obviously this is not working the way it should work. And as you might possibly predict, that's because we fucked around with the draw line function and we screwed it up. So apparently our swap function is not working the way we had hoped it would. The question is why? Why? Why are you doing this to me, Lisa? You're tearing me apart. So we could look at it and try to figure this out. But the easiest way is just to put a breakpoint here, put a breakpoint here, which is the case where we're actually using the swap, and see what happens. So here we're fine, and as we hit this point, okay, we've entered swap territory. Let's check out our variables. Okay, x1 is 400, x2 is 518. All right. So let's just write this down for posterity. Down here, x1, x2, x1 was 400, x2 was 518. I don't know. I have shit memory, people. Yes, 518. So let's step into this mother trucker, see what's happening. Okay, we'll step into this and we enter the swap function. And now our local variables to the swap function, x1 and x2, have been set to 400 and 518. We now move 400 into temp. We move 518 into x1. And we move 400 into x2. So x1 is now 518, x2 is 400. And x1, 518, x4. So yeah, they've been swapped, right? Apparently they have been swapped. So all's well that ends well, right? Wait a minute. x1 400, x2 518. But they haven't been swapped. But you said they were swapped. You said up here they were swapped, and now they're not swapped. So what the fuck, guy? What the fuck, bro? What's going on? I hope you guys understand what's going on here. If you don't, then you were not paying attention to me in lesson whatever the fuck it was. Basically, the reason why the swap function doesn't work is because it can't work. What happens is when you call a function, the function does not operate on the variables that you give it as arguments. It does not operate on these x1 and x2. What happens is the values stored in x1 and x2 get passed to the function, and they get stored into the x1 and x2 of swap. Swap then works on these local x1 and x2s, and then when it leaves, these local x1 and x2s, they disappear, and the x1 and the original x1 and x2 remain untouched because we never did anything to them. We just retrieved their values and then passed those values to the function. All right, let me elucidate on this point. I'm going to now destroy this background. There. Good night. Okay, so let's take the play-by-play of what happens with this function call. So we have on the stack, we have x1, we have x2. We have other variables, obviously. We've got shit tons of variables here. We got like dy, and we got dx, and y1 and y2, and r and g and b, but we'll forget about that shit. All we're interested in is we've got x1 and x2 on the stack at this point in our drawLine function. And they're both ints. Ints. Okay, so what are their values? Well, I believe it was 400 and 518. All right. And what happens? Well, we're going to call swap. So what happens when we call swap? Well, when we call a function, first of all, the compiler will create variables on the stack for each of that function's arguments or parameters. So the function swap has two arguments. It has two integer arguments, x1 and x2. So it creates on the stack x1 and x2, and they're both ints. Now you might say, well, we already have x1 and x2. True, but that x1 and x2 is for this part, is for this function, and this is a different function, so they can also have an x1 and x2, and that doesn't matter. So it creates the variables, the variables for the parameters of the function, and then in order to pass the values of the arguments to the function, it's going to retrieve the values of x1 and x2 here and copy them into x1 and x2 here. So this x1 gets copied into here, and this one gets copied into here. So, I mean, this is, I don't want to confuse you guys too much, but this is a different, this part of the stack is called a frame, and this is the frame for the swap function. It's separate from the previous frame, which was for the drawLine function. So these are separate. So it creates the parameter variables, and then it copies the values from the parameters into the parameter variables of the function being called. And that's how the value gets passed to the function. So the function, it doesn't know anything about these variables. All it knows about is these ones here. Next thing, we get to this line here, int temp is equal to x1. What happens? Well, compiler makes another variable on the stack here, temp, and then it stores the value of x1 into here. So that would be this x1, right? Because this is the x1 that belongs to the frame for our swap function. So 400 goes in here. Then x1 is equal to x2. So we assign the value of x2 into x1. x2 has 518. So 518 gets stored into here. 518. Yes. That's the worst 8 I've ever seen in my life. Okay. Last but not least, the value of temp gets moved into x2. So we move 400 into address 0045. And now we can see that the contents of our x1 and our x2 in the swap function have been swapped. Then we return from the swap function. And you know what happens when you return from a function? That function's frame goes like this. Blah, 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 die, 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 die. It gets completely destroyed. And the end result is that our original variables haven't changed one bit. So all that swapping work we done here, that was all just a big waste of time, just a big jerk off. I'm making the jerk off sign with my hand right now. It's a shame you can't see it. It's just total waste of time. And that is because functions pass their arguments by value. They retrieve the value from the argument, and then they pass that value onto the function. And the original argument is none the wiser. It never changes and doesn't get touched. Nothing. Can't touch this. Boom, 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 boom. I should put MC Hammer into this video, but I'm not going to, because I'll probably get like hit for copyright or something, and that would suck. So, what is the solution? What's the fix? Give me the fix, Chili. Well, I'm hoping you can think of the fix on your own. I'll give you a big hint. This lesson is about fucking pointers, bro. Have you got an idea of how we're gonna fix this shit? Right. Okay, so the way we get around this problem is we define our swap function as not taking... No, I can't find my pointer symbol. That's not it. Fucking Japanese keyboard. Fuck. There we go. We define it as not, the arguments not as being integers, but as being pointers to integers. So now the swap function, the arguments it receives are pointers to integers. Okay? And so because they're pointers, we have to use the dereference operator to show that we want to access the target of these pointers. Note that I'm not putting a star before temp, because temp is just a normal integer that we're using inside this function. But x1 and x2, these are pointers to our arguments that we use to call. So because they're pointers, we can access these arguments via remote control from our swap function. And isn't it sweet? So if we do this, we should be able to affect a change on these variables even though they exist outside of our function. Now I'm going to tell you right now that this code is going to compile with an error. And I want to know if you can tell me the error. Just think about it for a second. Think about it hard. And tell me why this is not going to work. It's close, but it's not quite going to cut the mustard. Okay, let's compile. And we get errors because we like errors. Cannot convert parameter from int to int pointer. Right. Because like I told you before, pointers, they don't give one flying fuck about your values. You can use your values to line your panties. Pointers want addresses. That's all they care about. Just give me your address. Bring the address. That's what they're saying. So we got to turn this value into an address. So now what we're passing to the function is not the value of x1 or the value of x2. It's the address of x1. And then that address goes into the pointer x1 here. And then the pointer is used to access the variable. Okay, now if I compile that, that should work. And I don't want to debug with these. Don't want this. And I got rid of the other one. Okay, let's go. And now, as you can see, I've got a full 360 degrees of motion here. Working like a charm. Like a boss, my friend. Like a boss. Fucking thing. My program is my mouse code is still kind of messed up a little bit. If I move off the screen too quickly, it'll still keep drawing that line. It shouldn't draw the line. Anyways, that's not important. What is important is that our swap function is now working. So finally, before I sign out, I just want to review what's happening with our new and improved version of the swap function. So we're going to analyze this line by line. So what happens is we're going to call swap with the address of x1 and x2. So again, it's going to create x1 and x2 on the stack in the new frame. This is the frame for our swap function. It's going to create x1 and x2 in this frame. And their type is int pointer. Pointer to int. And then it's going to move the values that it's going to pass. What? Give me that sweet. Okay, the values it's going to pass to the function are not the values of x1 and x2, but the addresses of x1 and x2. So it's going to pass these values to the function. And how it passes them to the function is it moves them into x1 and x2 of the swap function. So we're passing address of x1, so that's 0042 goes in here, and the address of x2, which is 0043. Then it creates an int temp in here, and then it says temp is equal to, I believe it was something like this, temp is equal to star, and it's like x1 or something, x2 or something. Where is it? Star x1. So temp is equal to star x1. How does that work? Well, first we look at x1. Its address is 0044. We retrieve the value of the pointer, which is 0042. And then we go to that address, which is address 0042, and we retrieve the value stored at that address, because we're using the indirection pointer or the dereference operator or the indirection operator. We retrieve the value at 0042 and then we store it into temp. So temp is now 400. Next thing. Oh, god damn it, I'm getting hungry. Gotta finish this tutorial up. x1 is equal to, star x1 is equal to star x2. Again, x2 is 0045. Retrieve the value of the pointer. The value is the address 0043. That's a 3, damn it. So now we're going to retrieve the value of this address, or the value at this address, 518. So we retrieve a 518. Now we look at x1. x1 is 0044. We retrieve this value here, which is an address 0042. And then, because we have the star here, we're going to store this retrieved value into the address 0042, which is right here. So we're moving 518 into 0042. And last but not least, x2 star is equal to temp. So what's happening here? What's temp? Temp is 0046. Retrieve the value at 0046, and we're done for the right hand side. Left hand side, okay, x2 0045, retrieve the value of the pointer, which is the address 0043. Now we're going to store 400 at this address, so we store 400 here. And finally, we return from the function, so that means that we have to clear this frame off of the stack. And what remains is x1 and x2, the original arguments, except that their values have now been properly swapped. Mission accomplished, people, and that is how pointers work, and I hope that was very clear, because I've thought about this a lot, and I tried to figure out how I'm going to teach this shit, and I think I've done a pretty damn good job, if I do say so myself. But if you have questions, feel free to pop by the forums and ask questions about this shit, because pointers, they are hard for a lot of people. So yeah, if you're unclear about some stuff, ask away. And fear not, we will be using pointers more and more later on. I haven't shown you any actual, like, why you would use this in a game or how you would use this in a game. I mean, I've showed you this example was swap, but this wasn't really necessary. This was kind of a contrived example. The fact of the matter is that pointers are essential if you're going to want to program games, because, I mean, DirectX, you can't work DirectX without pointers. You can't deal with the Windows 32 API without pointers. You can't allocate huge amounts of memory if you don't have pointers, because you need pointers to allocate dynamic memory, which we'll talk about later. Basically, you need pointers, but I can't show you why you need pointers because it's too complicated, and to understand those things, you have to understand pointers, but to understand why pointers are important, you have to understand those things, and blah, blah, blah. It's like chicken and the egg thing. So I've decided to explain how pointers work first, and later on, we will get onto where you can actually use them. So that's this lesson finished, basically. I just want to say one short thing before I sign out here. Yeah, fuck off. For the beginning lessons, every lesson I've tried to show you something, and then immediately I could show you how this will enable us to do something new in our game programming. Every construct that I've taught you has immediately increased the power of what you can express in your programs. But now with these more complicated topics, I can't just immediately show you, example, how pointers will enable you to do more cool stuff in games. It's not that easy. You have to use a bunch of shit together, and I can't teach them all at once. So I'm going to have to, there's going to be lessons here where I'm not doing so like a lot of epic shit with games and stuff. But I mean, now that we've gotten to this point, we're at lesson 16, so I'm guessing the guys who are watching now, you guys are in it for the long haul. So if you don't get your instant gratification in every lesson, I'm sure you'll be cool. So yeah, the next few lessons is going to be some theory like this, pointers and shit like that. And it's not all going to be fun and games, but trust me, this will eventually pay dividends in your game programming. So yeah, that's this lesson. And next lesson, I'm looking forward to teaching next lesson, actually, because we are not going to be working with the framework. We're going to be creating a project from scratch, and it's going to be a console application. So it's funny, usually when you're programming beginner level, you only code console applications and no graphics or sound or shit like that. And so it's amazing when you can finally do graphics. But I'm actually looking forward to doing the console now, because I've only been doing, graphics stuff with you. And some topics are actually easier to teach if you have text output and shit like that. So yeah, next lesson we're gonna be learning about text output and maybe strings and stuff. So yeah, look forward to that. I will be teaching you how to create a console application if you don't already know that. I'm looking forward to it, and hopefully, because I got some free time and I'm motivated here, the next lesson should be coming up pretty soon. And that is all. I'm done rambling. My throat's getting sore and I'm hungry. Peace out, y'all.
Oh, you touch my tra-la-la. My ding-ding-dong.